Hello, this is part 2 of the review. Just like before, the first thing you're going to need to have is this equal to 0. So you would add 10x to both sides. And you get 2x squared plus 10x minus 15. Make sure that is going in the middle because it has to go x squared, x, and then number. Now that it is equal to 0, you can set it up as a is equal to 2, b is equal to positive 10, and c is negative 15. This one is asking specifically for the discriminant, which, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. The discriminant is just this part here, the part underneath the radical. It is not the radical itself, just the stuff underneath. B squared minus 4ac. It's important because when you find that number and you try to square root it, one of two things will happen. Either you can square root it or you can't. And I don't mean like you can't simplify the square root of 2 or something like that. You can take the square root of 2, it's just not going to be a whole number. The only type of numbers you can't square root are negative numbers. So if this turns out to be negative, that means that there won't be any real solutions. So when it says describe the number and type of solutions, what it's saying is that if it's negative, there's going to be two imaginary or complex. Two imaginary solutions. If it's positive, then there would be two real solutions. The only other thing is that, well, there is a number that's not negative or positive, and that is 0. If it is 0, then it is going to be one real solution. The reason for that, just to kind of show you, if you had like 1 plus or minus the square root of 0 over 2, well, the square root of 0 is just 0, and if you add 0 to 1, that's the same thing as subtracting 0 from 1. So plus or minus 0 is basically nothing. So you would just get one answer of a half. There wouldn't be two answers. So 0 just gives you one answer, whereas if it was like 1 plus or minus the square root of 4 over 2, that you could actually get two answers from, because the square root of 4 is 2. And then you could do 1 plus 2 is 3 over 2, and 1 minus 2 is negative 1 over 2. So you get like two answers if it's positive. But as soon as you get something like 1 plus or minus the square root of negative 5 over 2, you can't take the square root of a negative. The most you could do is put an I in front for imaginary. And then there's two imaginary numbers, 1 plus I root 5 and 1 minus root 5, I root 5 over 2. So that's how that works. Now, everything I just said, it's just kind of an explanation. It has nothing to do with this specific problem. In this specific problem, the discriminant is equal to b squared minus 4ac. And b is 10 minus 4 times a times c. I still recommend squaring b in your head. I wrote it as 10 squared, but I strongly suggest not doing that. Just, hey look, b is 10. 10 squared is 100. 4 times 2 is 8. A negative times a negative is going to be a plus. And then it's whatever 8 times 15 is. I don't feel like doing it on top of my head. So 8 times 5 is 40. 12, 120. Woo! So you get 220 as the discriminant. So describe the number and type of solutions. Well, this is positive. And because it is positive, that means there is going to be two real solutions. So I would write two real solutions. Because the question says to find the discriminant, and right here it says describe the number and type of solutions. So there it is. Two real solutions, and the discriminant was 220. To find the actual solutions, you have to go back to do the rest, because this part is just the part underneath the square root. You would still have the rest of this. In front is negative b. In this case, b is 10, so you'd have negative 10. And then it's over 2 times a. In this case, 2 times a is 2 times 2, which is 4. It's possible to simplify the square root of 220. I'll double check it. So 2 goes into that 110 times, 2 goes into that as well 55 times. That's 5 and 11. So you make a number tree, and you look for 2 of a kind. I did make a video on this, so if you need to go back to watch that video, you can. You look for 2 of a kind, so you have a pair of 2's. And since there is a leftover 5 and 11, you multiply them to get 55. So this simplifies to negative 10 plus or minus 2 root 55 over 4. And here you can use the heart technique. Turns out these do simplify again because 10, 2, and 4 are all divisible by 2. And if you divide them by 2, you get negative 5 plus or minus root 55 over 2. Yeah, so the 2 and the 4, 2 cancels because 2 divided by 2 is 1. 4 divided by 2 is 2, and 10 divided by 2 is 5. And that's it. That's the actual solutions. This is what would go here. Okay, solve by completing the square. First thing you have to do is make sure it is just an x squared, not a 3x squared or negative 4x squared, I don't know. But this is just an x squared. So we can just go straight into using the formula b over 2 squared. That is the formula for completing the square. You keep the x squared minus 12x, you put the double blank, minus 27 equals 0. So it's just in between here, you put a double blank. When you use the formula, in this case b is negative 12. So negative 12 over 2 squared. So 12 over 2 is 6. And just remember, anything squared is positive. So this is going to get to be 36. So here, you'll put plus 36 minus 36. Once again, if I'm going too fast, just pause and rewind. So that's completing the square. B over 2 squared, you get that number, and that goes in the double blank, plus then minus. This will always factor in perfect square up there. In this case, what number multiplies to 36 and adds to negative 12? Hint, 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 it's always going to be the exact same number twice. In this case, what number added to itself is negative 12? And the answer is negative 6. Negative 36 and negative 27 is going to be negative 63, I believe. Yes, it is. Okay, equals 0. Let me zoom that up a little bit. From there, you would add 63 to both sides. Get x minus 6 squared equals 63. To get rid of the square, you would square root both sides, putting the plus or minus in front, as we all know and love. You get x minus 6 equals plus or minus the square root of 63. I will double check over here if you can simplify that or not with a number tree. 3 goes into it 21 times, and that's 3 times 7. So it does simplify because there's a pair of 3's and a leftover 7. So this is going to be plus or minus 3 root 7. And then in the last step, you would add 6 to both sides. So your final answer is x equals 6 plus or minus 3 root 7. Boom. GG. Next up, in this one, it does not say x squared, it says 5x squared. That is not allowed, so you have to get rid of the 5 by dividing. And look, these are all perfectly divided by 5. Cha-ching. X squared plus 4x when you divide by 5, and minus 6 when you divide by 5. So I'll have x squared plus 4x, double blank, minus 6 equals 0. So again, just between here, double blank. B over 2 squared. You look over here, it looks like b is 4. Please do not use this. Once you divide by 5, you are never going to use this thing again. That is the most common mistake. You don't use the 20, use the 4, because this is the equation we're using. This is the one where it's x squared, so the 4 over 2. If you use the 20, your answer is going to be way too big, and it's not going to be factorable, and everything's just going to go kaput. So here you go. 4 over 2 is 2, and 2 squared is 4. So plus 4 minus 4. So then what multiplies to 4 and adds up to 4? Hint, 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 it's the same number twice. You got it, it is 2. And these together make minus 10. So then you would add 10 to both sides. To get 10 equals x plus 2 squared. Square root both sides with a plus or minus. And get x plus 2 equals plus or minus the square root of 10. You can check to see if you can simplify the square root of 10. It just goes into 5 and 2, so there's no 2 of a kind, it doesn't simplify. And if you subtract 2, you get x equals negative 2 plus or minus the square root of 10. All right, just minus and stick it in front. Okay. Next up is the graphing parts. I'll put that into a third video, I suppose. So, see you in a minute.